Video number 3 of chapter 1. I love me some memes. I love me some Futurama memes. And this was already there. I didn't even make this one. I love just Googling histogram meme. And there's a lot out there, people. You'd be surprised. Look it up. So histograms. Histograms and bar graphs, not the same thing. Bar graphs graph more categorical variables, okay? And histograms are going to do more quantitative variables that involve numbers. Histograms do not have the spaces between them in their bars like bar graphs do, okay? Histogram bars are going to be pushed up, right up next to each other. Another thing is, if you think about the bars of a bar graph, if you switched around some of them, would it really make any difference? If we were talking about colors of cars and we had just say red, white, blue, and black. Let's say there's just four main color cars there. Red, blue, white, and black. Would it really matter if the red bar was the beginning bar or the last bar or the second bar or the third bar? It wouldn't really matter where the red bar went, right? It wouldn't matter. But in a histogram, where the bars go do make a difference because we are going to be going from smallest to largest on our horizontal axis. Okay, so if we're talking about presidents' ages here when they were inaugurated, we would obviously want to start with a number line. And who was our youngest here? JFK, wasn't it? Where's JFK? Kennedy, 43. We would probably want to start our histogram at 40, maybe 43. I don't know, depends. How wide we want each bar to represent, how many ages we want to go in it. We call that a bin, B-I-N. How many ages, how many numbers do we want to go in each bin? Do we want to count by fives? Do we want to count by threes, by fours, by tens? Who knows? Okay. So, Obama was 47. Is he unusually young? Let's compare and look at this histogram. So, to make a histogram properly, we're going to divide the range of the data into classes of equal width. Okay. So, let me jump one here. No. Okay. I decided to do ages of 5. So 40 to 44, there's 5 different ages that could go in there. 45 to 49, there's 5 ages. Notice that each one of these classes all contain 5 years. Okay, that is very important. You can't have one of these, like say 65 to 80. We can't really do that because then one bar is going to be like ridiculously wider than the others. That wouldn't make any sense. There's no uniform consistency in that. So that's one thing you need to make sure of, is that your bars include the same number of values within each of them. Okay. So once I counted them all up, which I've done here, we only had 2 presidents between 40 and 44, which is JFK and some other dude. Oh, Teddy Roosevelt. What do you know? He's 42. What? That doesn't seem right. I thought Kennedy was youngest. Who knows? Look it up. Ask Mr. Gordon. He'll know. Ask Mr. Ashby. He'll know. Anyway, so here is my lovely histogram. And for the most part, we're going to have the calculator make histograms for us. But occasionally, the calculator isn't perfect. It's going to make kind of weird histograms. Instead of this being at 40, if you put this in your calculator, it might automatically put it at like 41.3. And you're like, 41.3? Well, that's a stupid number to start a histogram out with. But you do have control over the numbering in the calculator. And we will talk about that at the end of this video. Okay. So now that I have my histogram here, let's describe the distribution, which again, that's an important phrase you will see time and time again. So first, the S. So if we say the distribution of presidents' ages at inauguration, because that's what we are wanting to describe here. And for the first S, we would say, hey, there's maybe an approximately normal shape. Okay, does it look like it's pretty bell-shaped? Sure. Is there anything else you could call it? Absolutely. Remember, we said you could call this, if you wanted to instead, symmetric. You could call it roughly symmetric if you wanted to, because it's not exactly perfect symmetric. It's roughly symmetric. You choose, symmetric or approximately normal. For the O, are there any outliers? I wouldn't really say there is. There wasn't like any 100-year-old presidents, and 35 is the youngest, and 42 was the youngest number we had. Maybe if we had 135 person, but then it would just be one person down here at the end, and then it would kind of look more skewed left than maybe approximately normal. So I would say only if there was like, you know, a mummy or a zombie president came back from the after dead, uh, you'd call him an outlier. For the center, I already did the numbers here for you, but the median is 54.5. Okay, and that's the number I'm going to use. I didn't use mean, which is probably the number you'd want to use, but we will talk again later which measures of center, mean versus median, kind of match up better with range, IQR, and standard deviation. So since I used median as my C for my center, I'm going to use the only thing we've talked about at this point, range, which is our max minus min. So we have a range of 27 years between our oldest president and our youngest president. Now, one thing I want you to notice here are these numbers here. The 45, for instance. Now, what if I had a president that was 45? Does a president that's 45 go into this bin or go into that bin? And that's why this is kind of an important thing to create. If we had a president that was 45, he would go into this bin and not that bin because I've classified it that way. But when you look at your graph, you might go, man, whatever this number is, which way does it go? Well, it always kind of goes to the right. So this 45 always goes in there. 50 goes there. 55 there, etc., etc. Here's how to do everything on your calculator. And I want you to do this. I want you to run through, and I hope you have your calculator with you. Okay? What I want you to do is with your calculator, whether it's 83 or 84, it doesn't really matter, make sure it's on. Go to the Stat button. If you look towards the top and you see the very kind of middle button, it's the Delete button. Right below it is the Stat button. So if you press Stat, it's already on Edit. It's already highlighted on Edit, so just press Enter. And there are our lists. List 1, L2, L1, L2, L3. And what I want you to do is go back and look at all of your president data back here. All of these numbers. And I just want you to start typing them into list 1. When you get done with 57, so if I type in 57, press Enter so it bumps down. And then press 61, Enter. And keep going all the way till you get to Obama. Where are we at? Here. All right. After that, once you got all your numbers in, then press the second button and Y equals, which is right above the second button. It's for that stat plot feature. Okay. Now, it's highlighted on stat plot number 1, so press Enter. And you're going to want to press Enter to turn it on. So now the highlight should be on the on. And then press down and go to Type. And if you look at Type, you should see one that really looks like a histogram. It's that third option right here. So go over to it and press Enter so that the highlighting stays on the histogram. Then for XList, it automatically says L1, which is where I put my data was L1. If you put your data in L2, then what you're going to want to do, so let's pretend you put all of these numbers into list 2 instead. Maybe you don't have a list 1 for some reason, and we'll talk about how to get it back. So let's say all your numbers are in list 2. Then right here, instead of L1, what you're going to do is press second and 2. And that's kind of the shortcut to give you list 2. And then this frequency thing, we're just going to leave it at 1. We just want to use one set of that list. Sometimes you may want to replicate it and have maybe 3 sets of that number. Maybe it's just a faster way of putting in the numbers. Now, if at this point you went to graph, you're not going to get something that looks very pretty. So what I want you to do is go to Window. And Window is to the right of the Y equals button. And I want you to change the negative 10, 10, 1, negative 10, 10, 1 to these numbers here. The minimum age a president could be is 35. The max we'll set at 75. We're going to count by 5s, which is what we did. And then the Y minimum, notice I put it at negative 3. You could just put it at 0 if you wanted to, but negative 3 gives you a little bit of space down below just to get some breathing room, if you will. And the max we'll say is 15. There's never been more than 15 presidents of one age. And we want to count by 1, one president per. This XRES, just leave it at 1. And then when you're done with that, you're going to want to press the zoom button, which is in the very top in the middle next to the window button. And then you can either scroll down to number 9, or you can just press the number 9 and it'll automatically go to it. And then you can look at your histogram, which should look like this one, roughly. Okay. Now in your calculator, here's what's missing. All of these nice labels, they're not there. Okay. That's kind of the one disadvantage about doing this stuff on the calculator. But if you just needed a rough idea of what the shape looked like, maybe get a rough idea of what the spread looked like and the center, you can use your calculator. If you have issues, if you got errors, ask me about it next day in class and we will determine what's wrong. There's usually a handful of little things, some things you need to clear out, some settings you need to clear, etc. So here's what our calculator gives us, but this is what we're going to be looking for, a well-labeled histogram. This is called a frequency histogram because it displays the count, the actual number of presidents on the y-axis. A histogram that displays the percent of presidents in each age is called a relative frequency histogram. Okay, so whenever we use the term relative in there, relative means percents. Frequency means count. So we're saying a percentage count, if you will, versus just a count, the actual number of. And here's what I want you to do to end out the video. This is what I'll be checking for the next day. I want you to take the CEO salaries, which aren't, just $145. These numbers are have been rounded to the nearest thousands dollars. So this is $145,000. Of course, in 1993, all these numbers are now probably in the millions and tens of millions, sadly enough. So that's what I want you to do. Bring it to class. Next day we will discuss it. And good luck to you. Bye-bye.